Hello everyone. Today's our topic is sequences. What is sequences? A sequence of real number is a mapping of functions from n to r. It means this type of function is called sequence. Okay, and sequence is denoted by this symbol, and n is set of natural numbers, r is real number, and also we can say that range set such that x1, x2, and dot 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 xn. Okay. This is, we can say that sequence, and this sequence also represented by xn where n goes to 1 to infinity. Okay, so next is our convergent sequence. Sequence xn is convergent if its limit of xn, it means limit n tending to infinity, xn is finite. Okay, so simply we can say that this sequence is convergent. And what is divergent? A sequence, again this is divergent if limit of xn is not finite. Not finite, it means this limit is goes to either minus infinity or plus infinity. Okay, and now what is oscillatory sequence? A sequence xn neither convergent nor divergent, or we can say that a sequence converges to more than one limit. Okay, so next is limit of sequence. So a sequence xn tends to limit L if limit of its xn term where n tending to infinity is goes to L. Okay, so our question is, show that sequence Sn is defined by these terms converge to 3. Okay, so suppose that this relation which is given by Sn plus 1 is equal to root 3 of xn. Suppose that this equation, let equation first. Okay, and now if we write the terms of this sequence, so terms of this sequence is s1 is 1 and s2 is under root 3 of s1, comma next term is under root 3 of under root 3. Okay, and so on. Okay, so now firstly we have to prove that this sequence will converge, and after this we have to prove that the limit of this sequence is 3. Okay, now clearly s1 is 1. Okay, first term is 1 and also it is less than 2 3. Similarly this s2 is root 3, also less than 2 3. Okay, and similarly if we take by equation 1, okay, so our s plus 1 is equal to root 3 of Sn, we can written as less than of under root 3 of s2 लिख सकते हैं. Sorry, this is not s2, this is 3. So where it comes 3, let us suppose Sn is also less than 3. So now we have to prove that Sn plus 1 is also less than from 3. Okay, so from this equation Sn plus 1 also less than 3. So why we are using this? So that we can say that using principle of mathematical induction method, so by mathematical induction we can say that all Sn terms is less than 3 for all n. Okay, now clearly all these terms is also greater than from 1 or 0. So Sn is bound between 1 to 3. Okay, also this sequence is So Sn is bounded, and also this is in increasing order. So we can say that Sn is bounded and monotonic increasing also. So we can easily say that this sequence Sn is convergent. Okay. So now this sequence Sn is convergent. Now we have to find the limit. So for limit of this sequence, let us suppose that limit of nth term is n. Okay. So by equation 1, we can take limit on both sides. So limit of Sn plus 1 is equal to limit of root 3 of Sn. And if limit of Sn term is L, so on the same way limit of Sn plus 1 is also the same. Now this limit goes inside, so this limit we take L. Putting this limit we get L is equal to root 3 of L. Okay, by solving this we get L square minus 3L is equal to 0, or L is equal to 0 or 3. But here L can't be 0 because all term is greater than of 1. So because S1 is 1. So now limit of Sn is finally is 3. And the last statement is, so our sequence Sn will converge to 3. So next question is our, examine the following type of sequence is convergent or divergent and or oscillate, where the nth term of sequence is given by this number. Okay, so how we check the sequence is convergent and divergent? Just find limit x tends to infinity of a. Okay, so find here this question is using minus 1 to the power n plus c. Okay, so break this number when n is even and n is odd. So limit n tending to infinity. Okay, so this an is if n is odd, if n is even. Okay, n is odd, it means n is 1, 1 plus 3 that is 4, minus 1 to the power 4 it means positive. So its value is n, and similarly if n is even its value is minus n. Okay, now find this limit by applying directly, because there is no indeterminate form. So by taking this limit we get this is infinity and this is minus infinity when n is odd and when n is even. So clearly this limit goes to two number, one is plus infinity and second is minus infinity. So that's why this sequence is neither convergent nor divergent. So this sequence is oscillating. So this an is oscillate. Okay. So similarly we can solve many questions.